Hi guys, this is Vineet and I welcome you to this video. Today's video topic is temporal tables in SQL Server, and this is a part 2 of this video series which I will cover in some parts. So we are covering temporal tables. Please watch part 1 of this video before proceeding ahead with this part 2, and that's very much essential. So before I proceed ahead, uh, let's go ahead and subscribe to the channel. So guys, please go ahead and subscribe. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon, select all notifications to get notifications regarding all my upcoming and future videos, and also notifications regarding the temporal table videos that we are releasing. So let me give you 5 seconds. Please go ahead and subscribe right away. Please see the subscribe button at the bottom of this video, or just below this video you will find the subscribe button. So guys, I hope you must have subscribed by now. So yeah, we can proceed ahead. There are some points to remember while watching this video. Please watch this video till the end to gain better clarity of the concept. And if it's possible for you, please watch this video twice or as many times as you like until the concept gets clear to you. Perform any exercises in your test and lab environments only. Do not touch any production environment or production databases. We would like to know your thoughts regarding our videos, so please do share in your comments, feedback and suggestions. We eagerly wait for them and would love to read the same. We have created some playlists for you to watch. Links for all these playlists are given in the video description area of this video. Some of our popular playlists are SQL Server Database Design, SQL Server Tables, Business Continuity, Indexes, Performance Tuning, Integration Services and Transact SQL. If we talk about this video pertains to the SQL Server Tables category as well as the SQL Server Database Design category. If we talk about the total number of videos posted on our channel, it's more than 260 videos at present. At the bottom of this slide, we have a channel page link as well. So I'm also including this channel page link in the video description area of this video. So please check that out. On my channel page link, you can find out all these playlists as well. So my channel page is also a good place to start. The reason we create playlist for you is because we feel that playlist is best way to learn. For example, if you want to learn about SQL Server Tables, what we would recommend is go to the SQL Server Tables playlist and watch out all the videos from starting till the end to gain better clarity into that particular area. Let's come back to today's topic, which is temporal tables in SQL Server. And let me take you to notes. So in our earlier videos, we had covered till demo 1 and demo 2. So we are covered till demo 2. And in today's video, we have to cover with start with demo 3, where we will create a temporal table with a user defined history table. So let's talk about that. Let's talk about creating the temporal table with the user defined history table. So creating a temporal table with a user defined history table is a convenient option when the user wants to specify a history table with specific storage options. So yeah, it lets you customize the storage options for the history table. Where do you want to store the history table, etc. And you can also specify different indexes that are tuned to historical queries. So that is one of the benefits. And in this particular example that we are discussing, this example, a user defined history table is created with a schema that is aligned with the temporal table that is created. So yeah, your historical table schema should be in alignment with the temporal table that is being created. And to this user defined history table, if we talk about this user defined history table, a clustered column store index and an extra non-cluster row store or B-tree index is created for pointed or point lookups. So we will create a temporal table, we will create a history table, and in this user defined history table, what we will do, we will create a clustered column store index. One index will be this, and we will also create an extra index which will be non-cluster index and a row store index, and it's also called a B-tree index. Basically, we are creating this index for point lookups. And once this user history table is created, the temporal table is created specifying the user defined history table. So first we will create the user history table, then we will define a temporal table and give reference to this history table as the default history table. And basically, if we talk about SQL Server, the term B tree, if we talk about it, they generally refer to the indexes. And in particular, row store indexes, SQL Server implements a B tree structure in the background. And this does not apply to the column store indexes or in-memory data store. So column store indexes and memory data stores are stored in a different way. And generally, the term B tree applies to the row store indexes in SQL Server. Now let me invoke the SQL Server instance. So here we are creating a temporal table with a user-defined history table. Let's invoke SQL Server and see. So guys, SQL Server is open. So let me go ahead and take you to SQL Server quickly. This is SQL Server. All right. So we are inside SQL Server database. So let's go ahead and create a department history table we will create, and let's use the AdventureWorks 2022 database. In my system it is renamed as my AdventureWorks, but in your system it should be coming as AdventureWorks 2022 if you have installed that database correctly. If you haven't, please go ahead and install that database. So let me trigger a new query against this database and we will write in some code. You may write that code along with me. So let's create a history table. So in this demonstration, what we will do, we will create a history table first. So you should use the create table statement and mention the name of the history table. And in our case, we are taking department history as the history table name. And let's define the structure of this table. So set the structure of this table, we will take some columns. Remember guys, we are creating the history table first here. So we'll take a department ID, which is an integer type column, and this will not be null. So here I'm defining the schema and all the structure of the table. Let's take department name here, and this will be a varchar type, and let's take 50 character storage, and let's take it as not null, and let's define the next column, and next column will be manager ID, the manager for that department, and this will be of integer type and it will accept null. The first two columns will not accept nulls, but yeah, this column can accept null. Next column I'm taking is parent department ID. Let's take that and let's take it as integer type and will accept null values. And let's take valid to and valid from. That is the requirement for temporal table and the history table. These two columns should be there. First column is valid from, and both of these columns should be of date time type. So I'm mentioning that date time 2 type, and this cannot be null. These column cannot accept nulls. And let's take valid 2 column, and this column will also be of date time 2 data type, and this also will be a not null column, cannot accept nulls. So this is the structure of the history table. So I think we should go ahead and create this department history table. Not sure why it is. So it is highlighting department history with the red underline. So it is. So when I point my mouse pointer towards the department history table, it is saying that there is already an object with the name department history in the database. So there is already a table with the name department history in the database. So we need to delete that table first. So let's go ahead and drop table department history. Let's do that. Not sure whether we will be able to drop this table. So the operation has failed because this is a temporal table, right? So this is a system version temporal table. So we need to turn off system versioning for this table. In my last video, I had shown you how you can turn off the system versioning for a particular table. Let me go ahead and do that for you again. So guys, if we take a look at left hand side, if we expand this database and the tables, let's try to locate this department history table. So we have a department table, but not the department history table. So if we expand this table, we see that the department history table is coming under the department tables. So both are system version tables. So we need to remove both of them. All right. So what we need to do is we need to turn off the system versioning, because system version table is department. We need to first turn off the system versioning for this table, and then we can alter this table and we can drop the period for system time, and then finally we can drop this particular table. So let's go ahead and turn off the system versioning for the department table, which is the parent table. So to do that, type in alter table, which table we would like to alter here. We are altering the dbo.department table. All right. And what we are doing is we are setting a particular property, which is the system versioning. So mention that system versioning keyword properly. And set this system versioning to off. All right. So let's do that. Let's turn off the system versioning for this table. So we have set the system versioning for off for this particular table. So let me check the status whether it is still showing as system version. So if we refresh this table, it is still showing as system version, but now you see the history table is gone. So it is not system version table anymore, although it is written over here, but I don't think so. It's a system version table because we have turned off the system versioning. So what we see here is now we have two separate tables. The history table is now separate from the department table. So we need to do another statement. We need to drop the period from the department table. The period columns are this valid from and valid to. Let's try to execute these statements. So let's do an alteration on table department. Let's do, although we can directly remove the table as well. That's also one of the options. So db department is a table, and let's try to execute the statement drop period for system time. All right, let's try to execute this statement and see what is the effect of this statement. So I've dropped the period from the db department table. Let's refresh the tables. So earlier we were seeing that valid to and valid from column. Now let's refresh the table section and see what columns do we see. Do we still see those columns under the department table? The columns are still there, but yeah, it drops something in the background. That statement is also essential. So let's quickly drop the department table. So let's do drop table department. So let's drop it. So we are able to drop the table. Let's see whether the department history table is still there. We have dropped the department one. Let's drop the department history. We can drop it directly. There's no need even to use this statement. You can drop, if you just want to drop them, you can drop them directly. So let's drop the department history table as well. So let's quickly drop this table. So both of the tables are now dropped, and if we refresh the section, we see that both of the table does not exist now. Now we can proceed with our example. We were creating a department history table first. So in this case, we are creating a history table first. So this is the code for that department history table. Right now, we should be able to execute this statement to create this table. So let's go ahead and quickly create a department history table with these specifications. So it is saying that there is some syntax error near the int. So your parent department ID is one and the same column. So I've separated it using space. So you don't need a space here. So let's execute this statement. So now the department history table is created, and we can refresh the table sections to see that it is in fact created in the. So we have a department history table here, and we can check the column structure. So the structure of your temporal table should be similar to that of your history table as well. So right now we see that history table is now created, right? And after you create the history table, we were talking about some of the indexes. So I need to create a column store index first. So you can watch out my videos regarding the indexes. So I'm creating a clustered column store index. So I'm creating a clustered column store index. You can watch out my playlist on indexing. There you can find videos about the column store indexes, so that you can check what those indexes are. Now, index name will be the ix underscore, let's take the name as department history, basically indicating the name of the table where the index is being created. And we need to specify additional items like on which table this index is being created. So if we talk about the index, it is being created on the department history table. So let's quickly mention that. So the table name is department history, on which we are creating this index. So this is the table name. And let's quickly create this index. There is no other option required. And when we are creating column store indexes, we don't need the column information. We can just specify the table name and we can directly create a column store cluster index on that table. So there's some issue here. So it is saying that column store spellings are incorrect. So you need to specify n. Let's execute this statement now to see if it gets created. It's not a column index, but a column store I need to mention. So right now it's correct. Create clustered column store. And after that column store, you need to specify index statement. Ultimately, it's an index. So we are creating clustered column store index. This is the index name, ix underscore department history, and we are creating it on the department history table. Let's execute this statement. Now the index is created. All right, so we have created a clustered column store index on the department history table. We don't need to specify a column whenever we create a clustered column store index. And now let's go ahead and create a non-cluster index now. So let me specify non-clustered and index I'm creating, and let's create the index. The name of the index is department history. I'm creating ix underscore department history, and let's specify some additional naming convention: id, periods, columns. So let's see where we are specifying this index. We are specifying this index on the department history table. And apart from table, you need to specify the columns where you are creating the index. So specify those columns here. So we are creating this as a composite index, and we are creating it on the valid to column, and we are creating it on the valid from column, and the last column we are creating it on is the department ID. So dept ID is the column name. So we are creating this index on 3 columns. These are those 3 columns. So let's quickly create that index. Now the index is created. All right. So after creating the index, what we are doing here right now is we are creating a temporal table. So in this particular demo, what we have done is we have created the history table first, which is this one, and we have created a clustered column store index, and we don't need to specify the column. And then we created a non-cluster index, which is a composite index on these 3 columns: valid to, valid from, and department ID. Now we will create a temporal table, and we will specify this already existing history table for that temporal table. So let's create a temporal table with the name department, and the structure of this table will be similar to the structure of the the history table which we had created. So the structure of this temporal table should be similar to the history table that we have created. Let's specify the column names, or what we can do, we can copy out the columns from top. So we can copy till here. All right. So let's copy it out. There will be some differences in the valid from and valid to columns. So by that, so 4 columns will be similar. There's a little bit difference in the definition of valid from column and valid to column. So let's specify the valid from column first. So it's of date time type 2, date time 2 type. And with these columns specifically, we need to specify the statement generated always as row start, and these are not null. These cannot be null. These columns cannot be null. And let's take the second column, which is the valid2 column. So specify the name valid2, and this will also be of datetime2 type, and we need to specify the similar statement. Sorry guys, you need to specify it here. Generated always as row nth, and this will also be a not null column. And in the end, you specify another thing, which is period for system time, and you specified the valid from and valid2 columns here. Earlier we had deleted this thing from the already existing department table, so this is what we were deleting. We were deleting the period for system time. So this is what we are deleting, what we were deleting from that table. So we are defining a period for system time, and we are using this valid from and valid2 columns. This is these last three lines. If we talk about, we define these lines specifically for temporal tables, and these are essential if you want to create a table as a system version or a temporal table. Now let's execute this statement, but before that, there's some things which are missing. So this is the table structure for the temporal table. In the end, outside the structure, what we specify here is we specify the with clause, and we turn on the system versioning to indicate that this is a temporal table. So you need to turn on the system versioning, set it to on, and along with that, you specify the history table, and we will specify the name of the existing table as which we had created. So history table is here we are specifying the history table name as dbo dot department history will be the history table for this temporal table. So in this case, this particular department history table already exists here on the left hand side. If you see, it already exists, and we are just creating a temporal table department and pointing the history table to be used. Department history should be used as the history table for this particular table department. So this is the complete definition, and we can execute this, and we will be done with our demo 3. So I've executed this statement. So it is saying that you should have a primary key defined. So there's some structure problem. So department table for temporal tables, there should be a primary key defined. So we are taking department ID as a primary key. So let's take primary key here. And we specify that this primary key should create a cluster index in the background instead of non-clustered one. Otherwise, if you don't even specify the word clustered, by default it creates a cluster index for any of the primary keys defined. So let's execute this statement now. It will execute fine. So this is completed, and we now see that a department table should appear over here. Let's refresh the table section, and we will see the department table. So here we have a department table which is a system version table, and it is using the department history table as its subtable or a history table. And we can check the column structure, and both the column structure of department history and department table should be same. We have same number of fields, right? So this is how you define the history table in advance, and later on you can use the history table while creating the temporal table. Alright, so we are done with demo 3. Let's see what we have to cover next. We have to cover demo 4, where we will add versioning to our non-temporal tables. So in this case, we have a simple table, and we are making that table a temporal table by adding versioning to it. Let's see how that can be done. So guys, there are some remarks regarding our previous example we had given, the demo 3. So there are some remarks like if you plan to run any analytic queries on the historical data that employs aggregates or windowing functions, creating a clustered column store index, basically here we are defining that clustered column store index as a primary index is highly recommended for compression and query performance. So if we have planned to query this history table in the future, yeah, it's better to create a clustered column store index as the primary index on this table, as it will provide a good compression and query performance. And if you plan to use a temporal table for data auditing, that is searching for historical changes for a single row from the current table, you should create a row store history table with cluster index. So if we are directly planning to query the history table, creating this column store index would be useful. And if we are planning to just query the temporal table, which is the original table, the temporal table, for any data auditing purpose or searching for some historical data through that temporal table, you should create a row store history table with a cluster index. So we should create a row store index. That is what it is meant. And if we talk about the history table which we had created here, this should not have a primary key, foreign keys, or unique indexes, table constraints, or any triggers. So if we just talk about the history table, this history table cannot contain any primary keys, foreign keys, unique indexes, any table constraints, or any kind of triggers. It can't be configured for change data capture. So if we talk about the history table, this table cannot be used for any change data capture, change tracking, transactional replication, or merged replication. So these are some of the limitations that this history table or temporal table cannot be used for change tracking, change data capture, transactional replication, or merged replication. Now let's come down to demo 4. Here we will add versioning to our non-temporal tables to make them the. So basically we add versioning to our non-temporal table to make them a temporal table, to make them system version temporal table. And let's go back. So you can enable the system versioning on an existing non-temporal table, such as when you wish to migrate a custom temporal solution to built-in support. All right. For example, you might have a set of tables where versioning is implemented with triggers. Using temporal system versioning is less complex and provides other benefits. So we may have existing tables or existing infrastructure or tables where the versioning is implemented with the help of triggers, but that is cumbersome. If you use the temporal table system versioning, it is quite less complex, and it provides other benefits like immutable history. We don't have to separately query the history table, so that is what we meant by the immutable history. And we have a new syntax for time traveling queries. It has a better DML performance. It has minimal maintenance cost. Now, when you want to convert an existing table, which is a non-temporal table or a simple table, if you want to convert that existing table, consider using the hidden clause to hide the new period columns. All right, so new period columns will be valid from and valid to avoid affecting existing applications that don't explicitly specify column names. So we should hide these columns if we are adding the columns new, this valid to and valid from columns to an existing non-temporal table. We should mark them as hidden so that they won't affect the existing application that don't explicitly specify these column names. For example, select star or insert without column list aren't designed to handle the new column. So we should hide these columns if we are making a non-temporal table to a temporal one. Now let me show you how you can do this. Let's trigger a new query. Don't use the existing query. So we are adding a versioning to a non-temporal table. So if you want to start tracking changes for a non-temporal table that contains the data, you need to add the period definition. Optionally provide a name for an empty history table, and SQL Server creates that for you. So let me show you how you can create the add a versioning or system versioning to the non-temporal tables. So in this example, what we will do is first we will create a schema with the name history. Let's create a schema history scheme. Let's specify the name, create schema history. So a new schema will be created. Let's quickly create that. So the history schema is now created. Now, okay, let's do something here. Earlier we had created department table. So let's remove let's make it non-temporal table. We'll drop off certain columns and we will remove the history table as well. So let's do that. So in order to make it non-temporal, let's turn off the system versioning from the department table. So we are done with that. Let's alter that table department and drop period for system time. So this is also done. Let's refresh this section. So we have refreshed. Now department and department history are two separate tables. So we can drop, we don't want to drop the tables here. Let's drop the department history. Let's drop department history altogether. Let's drop this table. So department history is now dropped, and we want to modify the department table, and what we can do is we can drop off these columns here, the valid from and valid to. These are not required anymore. So this will become our, once we delete this column. So this is a normal row store table now with 4 columns. This is a simple table, not a system version or a temporal table. Okay, so this is a simple table with 4 columns: department ID, department name. Let's modify this column or rename this column so name spellings are incorrect. Let's define that. So department name is the column name, and manager ID and parent department ID. So the first column, department ID, is a primary key which cannot be null. So these 4 columns, and this is a simple table, not a temporal table. So let's go ahead with our example. So here we will be altering the department table to make it a temporal table once again. So if you have a simple table like this one, in this example we have a department table which is a simple table or a non-temporal table. Let's write in some statements. So we need to alter that table if you want to make that table temporal table. So let's alter the department table. So let's alter this table. What we will do, we will add in 2 columns. Those 2 columns are required, the valid from and valid to column. So you need to specify the add clause, and you need to specify the name of the column. So we are adding the valid from column, valid from, and this will be a date time to data type column, and this is a special column. So we need to specify the statement generated always as row start, and this will not be null. So let's specify the not null explicitly. And apart from, before even specifying it as not null, let's specify it as hidden. So this should be a hidden column. We need to specifically use this keyword, so that hidden column. This hidden keyword we have to only used in the situations where we are using a non-temporal table and making it temporal. Then only we need to specify this clause. Here we need to define the constraint here. So let's specify the constraint for this column. So it has a constraint, and let's specify the constraint name, which is df underscore department valid from is the constraint name here. So let's specify this constraint, and this will be a default constraint for any default values. So the default value for this constraint is, or column is, let's take sys utc datetime function to get the values for this column. Similarly, we can specify the another column. We can add valid to column, valid to, and this will be of datetime 2. And you need to specify generated always as row start. Here it will be row n, not row start, and this will be a hidden column as well. And after specifying hidden, you need to specify the constraints, right? So let's add a constraint. The column definition so far is looking okay to me. Don't know why it is highlighting. So it is saying something like incorrect syntax near valid to, but looks syntax is quite correct to me. Syntax is correct, no issues with the syntax. Let's see later on what's the issue with the syntax. So we are entering another column, which is the valid to column. Okay, let's add a constraint. constraint will be df underscore, which is a default constraint on the, here give the complete name department. Let's take this name here, department, and let's mark it as valid 2. And this will be a default constraint again. So let's specify it as default. So we are creating a default constraint, and the value for this column will be coming from convert function. And here we are taking a specific value for that column. So the default column for this column would be of datetime type 2, and specify the column value. In this case, we are taking a particular date. So you need to specify that date, which is the maximum date. You can specify it over here. So 31st, and time would be 23:59:59 would be the last time under that date. And under the milliseconds, you can take 7 times 9. All right. So this is the default value we have specified. Let's close the bracket and put a comma here. So this is done, and let me see. And you need to specify the period for clause, and that is also required. So let's define period. Period for, that's the general clause we use while defining the temporal tables. So we are adding these two columns and defining a period for clause, and let's specify system time, and we take valid from and valid to columns to make it a temporal table. So valid from and valid to. So this structure definition is complete. Not sure why it is giving the error messages. Let's use a semicolon here. So this is a separate statement. Let's try to execute this statement. Let's see. So it is saying some issue. So add keyword needs to be used only one time. So let's specify that keyword over here. This needs to be used only one time. We don't specify add several times to add different columns. So just specify add one time only. All right. And this is the correct definition of this alteration of the non-temporal table, and I'm making it temporal by adding the valid from column, taking it as a date time to column, specifying the generated always as row start clause, and I'm marking this column as hidden. Similarly, we are taking a valid to column of date time to type and marking it as generated always as row end and marking it as hidden. And whenever we are making a non-temporal table to a temporal table, we are converting a non-temporal table to a temporal table. What we will do, we will add constraints manually. So for valid from column, we have added a default constraint to use the system UTC date time, and for the valid to column, we have defined the default constraint that we will take the maximum value of the date as the under the valid to column. If no, generally we don't specify values for valid to and valid from columns, so that's why we are defining the default constraint. And lastly, we have defined the period for system time clause, and where we have taken valid from and valid to columns, and this is basically a structure to make a temporal non-temporal table a temporal one. So let's execute these statements. Now department table is now converted from a non-temporal table to a temporal one, and so far we have just added these three columns. We haven't turned on the system versioning for this table, so we need to further alter this table. So let's alter this table, department, alter table, departments, and basically we need to turn on the system versioning. So let's turn on the system versioning. So let's set it to on. And apart from that, we need to specify the history table name. So far we don't have history table with us now. So let's take history table. specify it as history table, give equals, and give the name of the history table. In our case, let's create that history table under a new schema. We will use no new schema for that. Let's use history. Let's use history and specify the new table. So the new table, we can use the same table name. We can use the same table name department because we are creating this history table under a different schema. So the department is under the DBO schema. This new department table will be the under the history schema. So we can use the different schema to store this history, and we can use the same table name if schema name is different. So let's use the same table name here. The reason we are able to use the same table name here is because this table name is using a different schema. This one is under the DBO schema, so we can specify the schema as well here. So these two are different, altogether different tables stored under different schema. History is stored on being stored under the history.department, and your temporal table is department. Let's execute this statement, and one bracket is missing, so let me put that on. So this is the complete statement. Let's turn on the system versioning for department table, and we are specifying the history table as well. So execute this statement. Now let's refresh the table section on the left hand side, and let's see what we will get. So we have a department table, which is now a system version table, which is indicating that it's a temporal table, which basically stores the version history. And under that, we have a history table, which is created under the history schema. History.department is the history table for this temporal table. It has the following columns. These 4 columns were previous columns, and valid from and valid to were added. And similarly, the history table also has the same number of columns. And here we have specifically marked valid from and valid to columns as hidden. So if we query the department table, it will not show us the valid from valid to column by default. Whenever we use like select star from history.department, it would not show us the valid from and valid to column details. All right, so this is done. I can show you an example. So let me query the select star from the department table. So let's execute this statement. Let's see. So here department table, we have separate objects under different schemas. So we need to specify the schema as well. Whatever table we are referring to, specific exact table. So here we are referring to DBO dot department table. So let's execute that. So if we execute that, by default we don't get these valid from valid to column if we mark those columns as hidden. So here we have marked these columns as hidden, so they will not show up in the regular select star queries. So guys, we are done with this demo 4, where we had discussed about how you can add versioning to a non-temporal table to make them temporal. Let's see some remarks regarding this. Then we will focus our attention on demo 5, which is how you can migrate the existing tables to built-in support. So in this video, we will keep up till this demo 4. After discussion of remarks, I will close off this video, and we will start with demo 5 in our next video, which is video 3 for this video series on temporal tables. We will cover the demo 5 in that next video. So you should be subscribed to my channel if you want to get notifications regarding my new video released. There's a subscribe button below this video. Please use that button to subscribe. So guys, we are done with this video, and we are done with demo 4 as well. So in today's video, we have covered demo 3 and demo 4. In demo 3, we have discussed how you can create a temporal table with an existing user-defined history table. And in the demo 4, we have discussed how you can make a simple table or a non-temporal table to become a temporal table by adding the versioning to that table. So we have discussed these 2 demos. Please go through these 2 demos in detail, and watch out this video again carefully. If you don't understand the video content in first attempt, you can give it another attempt. And also guys, it's very much important that you should be familiar with the part first of this video. So please watch out the part first before you continue with this video. So that's very much essential. Let's come back to our today's topic, which is temporal tables in SQL Server. This is part 2 of this video series, and we will cover the rest of the demo starting demo 5 in our next video, which will be part 3 of this video. And we are done, guys, and I hope you like this video, guys. Please click on the like button just below this video if you really like this video, and also, guys, please subscribe to this channel if you want to get notifications regarding any of the future videos or any of the future parts of this particular video. Please do subscribe. There's a subscribe button below this video. Click on that subscribe button. It will give you a bell icon. Click on that bell icon. Select all notifications to get notifications regarding all my future upcoming videos, and also notifications on the parts of this series, temporal tables. And guys, do post in your comments, feedback, and suggestions regarding our videos, and maybe you have some requirements regarding some of the content in some other area. Do let us know about that so that we can create videos in that particular field or area. So only upon receiving your request, we will try to create videos in those areas. We barely receive comments from you, so I would urge you or request you to please post in comments. We do like to hear you. And also, guys, if you have a good network of friends, please ask your friends to subscribe to my channel, and you may share my videos with them using the share button which comes below each and every video. You can use that share button to share my videos with your friends over any of the social media platforms. So that is the help we require from your end, and I thank you so much for your time on this video today, guys, and you have a wonderful day ahead. Thank you.